So good afternoon. So in today's lecture series, now we are going to discuss one of our second order system which you call it as the undamped system. Called as the undamped system. Now in our earlier lecture series, now we have discussed the classification of your second order system based on the damping ratio. So the first system you call it as the undamped system where our the damping ratio is equal to 0. So consider the second order general equation which is given by C of s by R of s is equal to omega n squared divided by s squared plus 2 zeta omega ns plus omega n squared. Now it is a general expression given to our second order closed loop transfer function, and here in this case now undamped system your zeta is equal to 0, so your C of s by R of s now it becomes omega n squared divided by, now our zeta is 0, so it is s squared plus omega n squared. So here in this series we are going to find out the response of a undamped system for a unit step input. So consider our input R of s is a unit step input now which is given by its Laplace transform, so it is 1 by s. So R of s is equal to 1 by s. So our C of s now it becomes omega n squared divided by, so R of s goes over here, so it is s into s squared plus omega n squared. So this is our C of s. Now our main job is to find out what's the response of this equation. So just like that we cannot find the response. So this equation, now we have to split the equation by applying partial fractions. By applying partial fractions for the above equation, now your C of s is equal to omega n squared divided by s into s squared plus omega n squared. Now can be written using partial fractions as a divided by s plus b divided by s squared plus omega n squared. Now cross multiplying this equation, now we get omega n squared is equal to, it is a into s squared plus omega n squared plus b into s. Now here a and b are the coefficients. Now to find the value of a and b, so for that first put s is equal to 0. So we get omega n squared is equal to, this term it becomes 0, s squared 0, so it is a into omega n squared, which implies our a is equal to 1. Now next case you put s squared, now this a has to become 0, so s squared is equal to minus omega n squared to the above equation. So what happens is omega n squared is equal to, so minus omega n squared, so this gets cancelled, so from which now here it is just s, so s is equal to, so you just take the root, you get minus j omega n, minus j omega n. So therefore our equation becomes b into minus j omega n. Now when you just, so in the second case, now we will put s squared is equal to minus omega n squared now to the above equation. Now what we get is omega n squared is equal to, so this entire term will become 0, so it is minus b into omega s squared, sorry, s is then s squared is equal to minus omega n squared, which implies s is equal to, it is j omega n. So here yes, I'll put it as j omega n. So this, so it is b into j omega n. So now this omega n, 1 omega n gets cancelled, you just bring j to the bottom. So we have found out the value of a and the value of b. Now substituting the value of a and b, we will consider this as equation number 1. Put in equation number 1. Now we get our C of s is equal to, it is a divided by s, so a is 1, so it is 1 divided by s, minus b is j omega n, which we can write it as b is equal to, j omega n is nothing but s, so b is equal to minus s, so it is minus s divided by s squared plus it is nothing but omega n squared. So C of t is nothing but the Laplace inverse of C of s. So therefore taking Laplace inverse for the above equation, now it becomes 1 by s is 1 minus s divided by s squared plus omega n squared. It is cos omega n into t. So this is our response for a second order undamped system. And when you just draw the response, so with respect to time, your response c of t, now you can see it is just only oscillation because we don't have any damping factor in our response. The equation just consists only of cos omega n, which is nothing but an oscillation. So a second order undamped system, since it does not have any oscillation, the system will not reach its final steady state. So therefore such a system cannot be applied for a practical case. So thank you for listening. We'll meet in the next lecture series. Thank you.